So I'm Seena Handel. I'm forest resource management planner with the Alberta government. I help companies develop their strategic forest management plans. And my counterpart is Fauve Blanchard. She's a wildlife biologist at a Whitecourt. Okay, so I'm going to give you guys a crash course. There's very few foresters in the room, so I'm going to give you a crash course on forest planning, strategic forest planning. And so essentially I'm going to take a 2.5-year process and boil it down into 3 slides. So get your crash helmets on. So forest companies, they have forest management agreement areas, and inside that forest management agreement, it says you have to do a forest management plan, which is a 10-year strategic plan. It takes multiple values across the landscape, and you incorporate them into a map. And one of the outcomes of this plan is a map that shows a spatial harvest sequence that shows you where you go, and an allowable cut. Allowable cut is it's expressed inside cubic meters per hectare. And then you have your proposed harvest sequence, which is your spatial harvest sequence. In Alberta, there's 18 FMA holders, so we're going to do 18 plans on a 10-year rotating basis. Okay. So this map here just shows an outcome. This is what would be one of the products out of this strategic plan. So this would help companies then go from a strategic level down into an operation level. So one of the big questions is, what's the difference between a strategic plan and an operational plan? Strategic plan is something that talks about what kind of serial stages, so what kind of age class structure you want across your entire landscape. Site-specific information, like how you want to protect a stick nest, that is an operational item, and that's covered off inside each company's operating ground rules. So there's an example of an annual allowable cut, and it shows up usually in a deciduous volume and a coniferous volume. So how do you do this? So there's a couple things that happen. So the first one you have is the forest companies take an inventory. It's required to start a forest management plan. You have to take an inventory, so forest inventory, and we call that AVI, Alberta Vegetative Index, or inventory. So the AVI. So then a company determines where they will harvest and where they won't harvest on the landscape. And companies create volume or yield curves, and yield curves are important because that's what we ended up doing. So tree volume yield curves, and then they use timber supply analysis. There's a special breed of foresters who do that kind of work for us because they like calculus. And so one of the models is called Patchworks. You can use Patchworks. There's a couple of different ones. Patchworks is very popular. Or very common, and it makes some decisions based on some values. So that would include songbirds, for example, or it would include producing timber over a 200-year planning horizon, and then you optimize your AAC based on some of those decisions there. So one of the things that we had as a forest management branch, we had the hurdle of how do you assess these plans that come in across the entire province. How do you assess them and ensure that see what they're doing and what their impact is on fine filter species. So Fauve and I embarked, along with a collection of other people, on a process to develop a model and develop a process to assess those forest management plans that are submitted. So Fauve's going to tell you about the model.
One thing I want to emphasize is, in the past, a lot of these models were done on forestry companies. That isn't a new thing. They have modeled fine filter species. But in the past, they always did it after they've already produced their spatial harvest sequence. So at that point, it's really costly to go back and rerun it or modify their spatial harvest sequence at that time. So it would have to be a pretty major loss of a species in order for that to occur. One thing we were able to do with the songbird model is have it so it was really easy to integrate into that patchwork system, so that they can do it in the front end and actually optimize for this the same way they would do for their AAC or patch size or any of these other variables. So that was a great thing about this. I'll give you the very basics about how we use the songbird model. So first we chose 5 species: black-throated green warbler, brown creeper, ovenbird, Canada warbler, bay-breasted warbler, or varied thrush. So bay-breasted warbler and varied thrush were switched depending on where the FMA is in Alberta. These are chosen because of the range that they do overlap with Alberta boreal forests. They're either sensitive species, they had low confidence limits when it came to using ABMI's coefficients, and I'll get some more of that here soon. So how we made the model: we took ABMI's habitat coefficients and we translated those to the AVI stands. It was a little bit difficult because the ABMI habitat coefficients, there we go, down here, are very different than the AVI categories. So luckily ABMI had a Python script to translate it to AVIE, but the companies use AVI, so we had our FMB GIS analysts kind of detail how to make sure that each company knows how to translate that as well. So it's kind of a 3-step process, but we made it fairly easy. And so now every AVI polygon out there has a habitat coefficient relative abundance for each species. In addition, we added the modifier coefficients, which are based on linear coefficients for soft and hard features. So soft being vegetated, pipelines, cut lines, and hard linear features being like roads, railways. To integrate these, we actually made a 7-hectare provincial grid throughout the entire boreal forest. So every FMA overlapped this grid. And with the package, we would send the grid to the companies. We use 7 hectares because the point data that ABMI uses, 150-meter buffer. It is circular. We made it square, but the area is the same, so we figured that was kind of an assumption. So now every AVI polygon has there's a grid throughout. In every grid cell, every AVI polygon within the grid cell has a species-specific habitat coefficient and linear feature adjusting factor depending on the linear features in there. For hard linear features, it was 1%, anything above 1%. For soft linear features, it was anything above 0.1%. And so in total, we're able to produce a relative abundance for every AVI polygon and then add that up to the FMA. We counted it to compartments as well, because then we can start to do some strategic mitigations at a compartment level if needed. And so as the non-timber committee, we had this provincial risk matrix we developed using the IUC category, so we didn't come up with these numbers. And to identify kind of a provincially consistent direction to companies saying, try and minimize the risk, but if you can get it less than 15%, we consider that low risk for that species. And not just for year 10, but ongoing as well. Of course, as you get to 100 and 200 years, you're a little more lenient with these risk levels, just because the yield curves and everything, it kind of becomes more variable at that time. And then depending on whether it's low, moderate, or high risk, the requirement for mitigations or the requirement to rerun the model to change our SHS, whether we'd accept it or not, definitely varied depending on how much it changed. So luckily we had Miller Western was the first company to test this out. I was very grateful for their patience and kind of trying to figure this out in the process. But we've got some of their output. So this is just one of the species, but what's great about this model is you can produce a spatial output showing the different relative abundance for every species for year 0 all the way up to year 200, as well as some awesome looking graphs, which actually get produced right out of Patchworks. You can integrate in those 15%, 30%, things like that, and you can optimize it, which is great. So a great example we had was black-throated green warbler. Their initial run, it showed that black-throated green warbler populations would drop below 15% based on their first spatial harvest sequence. We asked them, can you adjust for that and keep that black-throated green warbler population within that 15%? What would be the impact on their AAC? Luckily, it wasn't very much, and we were able to bring that back, and they were willing to do that. So it is kind of right against the line.
So when we were developing this model and the associated process with this, we had we're like, what what did we learn? So here's some things that we learned. So I'm gonna say something big here. How to be a biological legend, right? So how do you have your research go in and impact a significant part of the Alberta landscape for 10 or more years, right? Like that's a pretty, like, not only did I write a paper, but it's being used, right? So how do you do that? How do you be used? So here's my pointers. So there's the forester in the room. There's like 3 of us in the room I recognize. So you need to use a common language and common set of tools. So one of the big things that we learned at the start of this process is that some models, they relate birds to the DBH of trees within the stand. We don't have a way of assessing DBH on a large inventory way. It is a significant barrier to be able to use that kind of information. A much better thing, like Mark said previously, is tree height or tree age. We know how old things are, and we reassess that with every inventory. So every 10 years, we go in and we find out how those things are. The other thing about those is we can grow those things. We know, like, is you can age things over every 10 years in our plans for 200 years. So we age things. So that's really important. So age of trees. The other key point is merchantable trees, because lots of times papers relate things to the understory, like alder, willow. They don't grow very good 2x4s. Forest companies aren't so interested in that. So when you're considering, if I want to relate my trees, my bird of interest to something, what do I relate it to? Relate it to in Alberta, fortunately, we have about 5 major economics tree species, so those would be the ones to go for. There is a couple forest characteristics that are assumed to stay constant over time. One of them is your species composition. So if you have 80% pine in a stand, we're going to assume that when that stand is cut or burned over, it's going to come back to 80% pine. So there's some things, but that also relates to understand your user's business, right? So if that's a big way to have your research go on and continue to be relevant. Yeah, and using diameter, it is a significant barrier to being used. Kind of the point where we didn't end up using any papers that related birds to diameter because it was a big barrier. How to continue to be a legend. So your updates, one of the things that Fauve talked about is we created this model and we plugged it into the side of Patchworks. So that's why we have the plugins, so that we can continue to plug in as time goes on. So if how our model is being updated, if that plugin isn't consistent, then we have some problems, and it limits the usability of this particular model or that paper. And one of the things that happens with forest companies, they're very interested in showing where things currently are, because we understand things change quite significantly over time. So instead of using photography that doesn't get updated very often relating to a tree species or a height that can be updated as part of a forest inventory, that's also a good way to maintain the applicability. Don't be afraid to quantify some thresholds and quantify what happens at this age. This happens to all the birds fly away and they never come back to this stand. Something like that. I don't know. I'm clearly a forester and not a bird biologist. One of the other pieces of advice there was you can build, because of the computing power that we have out there now and the programs available through ArcView and ArcMap, you can build models with complex relationships, especially spatial relationships. So if you have a grid of 7 hectares and only parts of that area are suitable for birds and other parts are unsuitable, that can be used, right? So you don't have to be afraid with that part. My only caution to that is that those complex spatial relationships are harder to forecast in time. So we've created a model like the model that we created for barred owl cannot be forecasted in time because it would blow up the computer to make it try to forecast that spatial relationship. It can't do that. And again, sensitive species, but not too sensitive there, so we know something about these species. The other 2 pieces of advice we got about were if your model can predict for how management on typical land cover, what that impact is going to be, and then inform more species-specific relationships to covariates that might drive abundance or use or occupancy. And then also when you're concluding your paper there, if you can be clear about how you think this could be used in forecasting and why, because that takes all the guesswork out for us people. And then I've got a couple industry partners in here. How to be a fantastic industry partner. One of the complaints was that AVI is very difficult to get a hold of because of the cost associated with capturing it. But sharing that has a benefit for all of us, right? We all want to ensure that we're achieving sustainability for multiple resources, and this is one of the ways of doing that. So one of the questions is, where's the knowledge gaps and where's the areas for improvement? So,
just going back to talking about the model areas for improvement of this model, it is a very, right now, simplistic model. It does take into account only relative abundance. It doesn't take any productivity or survivorship into it. But actually hearing Mark's talk right before this, there's a bit of excitement, I think, in me that maybe we can get some nest density factors into this model that would help that. As well as if we had survivorship, identifying where sinks are, and kind of narrowing even spatially where are we going to be protecting these species, as well as territory sizes. So that was something that came up with the barred owl model. That was fantastic. We had the barred owl model. It was Russell 2008 that we used, and we had the RSF factor that was modified and it worked. Unfortunately, the breeding pairs component didn't, and it's because the breeding pairs actually identifies not only that there is habitat out there, but because barred owls have such a high territory or a large territory size, they weren't able to, or currently they're having difficulties maintaining that. So you may have the right kind of habitat out there, but if it's not connected spatially in a way that species can use it, there's complications. That might not be as big of a deal when it comes to these songbirds that have a much smaller territory size, but that's something I think that might be worth looking into. As well as climate change. Everything's changing, so if we're using all the point data from a long time ago, maybe it's not the same now. One thing we wanted to emphasize, though, is I do want to improve this model. Unfortunately, GOA is not as flexible as maybe some of the researchers out there, especially we have a lot of industry partners that are asking for the model packages. We've contributing with other budget and time resources within house. So we do want to update this. We will update this at the same time we update the whole non-timber document. However, I can't expect that as a yearly thing. But yeah, anything that these grad students or researchers out there can help to improve, we're more than welcome to listen. I'd love to improve this model for the next time that we change it.
So just a few more slides left here. So some of the other knowledge gaps, one of the other things, like pileated, I don't know how to say it, the bird, that red thing on its head. So that was one of the problems, one of the barriers with that one right now is that lots of the research relates that to dead trees. Forest companies don't really care about dead trees. We have a hard time knowing how dead trees change over time. So if you want to be a legend, there you go. You can associate pileated woodpecker and see how they relate to live trees. And then, so one of the other knowledge gaps, so just taking existing research that's out there and validating it for other parts of the province, that would help us out. That would be able to increase its applicability. It's not very glamorous, but it sure is useful. Another comment was the northwest part of the province, the combination between Rick's heat map showing where some of their research projects are and where EBMI works, there's still some gaps out there in the province where there's ground out there where we don't have a lot of knowledge on. And any questions, and we just want to take a moment to say thank you to Miller Western and Bob Mason there.